We're on problem 13, section 2 of the College Board online practice test. The problem reads, if the equations above are true, which of the following is the value of y plus z? So we've written down our two equations here, and we're looking for the value of y plus z. So I'm going to write that here so we remember what the question is asking. Okay, so this problem can be overwhelming because there are three different variables and you're used to just solving for one variable using just x and y. Well, the easiest way to solve this problem is to make the two formulas equal each other and to try and get rid of some of these variables. So the first thing you should do is try and see what the two equations have in common, because that's going to help you make them equal to each other. So in this case, the factor that they have in common is this 3x. Okay, so we know that they both have a 3x and it's separate from any other number. So we're going to try and make the 3x stand on its own for each equation. So equation number 1, we're going to do 3x equals, alright, so I'm going to equal it to 19, which is on one side of the equal sign, and then we're going to bring over these other two to the other side of the equation. So equals 19, we're going to subtract 2y from both sides, so minus 2y minus 2z. Okay, same thing for the other formula. Let me circle this so we don't get confused. Okay, formula 2. 3x equals 14 minus y minus z. Okay, so we know that in both cases 3x equals either this formula or this formula. So we can say since 3x equals 3x that these two formulas must equal each other, right? Okay, so then we're going to write 19 minus 2y minus 2z equals 14 minus y minus z. Alright, so as you can see, we've eliminated the x from our equation here, and we're just left with y and z, which are the variables that we want to solve for. So now the trick is to get y and z, or y plus z, to one side of the equation and get everything else on the other side so we can find out what y plus z equals. Okay, so how do we do that? Let's bring all the y's and z's to the left and all the non-y's and z's to the right. So we're going to keep the negative 2y and the negative 2z, and we're going to bring the 19 over here. So we have negative 2y minus 2z equals 14 minus y minus z minus 19. So basically I just subtracted 19 from this and from this side, so it crosses out on the left side of the equation and it only stays on the right side of the equation. Okay, so now we have some y's and z's on our right that we want to bring over to the left. So we're going to do, let's see, negative 2y minus 2z equals, plus y, because we're bringing our y to this side. So plus y plus z equals 14 minus 19. Okay, so all we did is we brought our negative y and our negative z from the right side of the equation to the left by adding y and z to both sides. So now we have some like terms on each side of the equation, so let's simplify that as much as possible. We have negative 2y and a positive y, so if you add that, it leaves you with 1 negative y, or negative y. And then we have negative 2z and a positive z, so that leaves us with minus z equals 14 minus 9, which is negative 5. Okay, so we're close now. We're almost in this format, y plus z. However, the y and the z are negative. They're both negative, and we need them to both be positive. So we're going to multiply each side by negative 1. And I'll show you here. Because remember, everything you do to one side, you have to do to the other side of the equation. So negative 1 times negative y is positive y. Same thing for z, positive z, equals negative 5 times negative 1, which is positive 5. And here you have it, y plus z equals 5. And let's look at our answer choices. What do you know that is answer choice E, which is the correct answer to this problem? So really the trick is just, again, finding the common variable or the common term in the two equations so that you can set the other sides of the equations equal to each other and then reduce the number of variables that we're working with. And we always want to keep the variables that we're trying to find in our equation. So in this case, we're trying to find y plus z. So we want to get the x's out, which we did by using the 3x as the common term. And then, as you saw, we were only left with y and z down here in these equations, and it made it very simple to solve for y plus z.